Hey guys, welcome. There are a lot of programming languages in the world today, such as Java, JavaScript, Python, C, C++, C#, PHP, and so many more. But arguably one of the most easiest programming languages that you can learn is SQL. SQL is not just easy to learn, but is also one of the most widely used programming languages in the world. SQL is not just used by software developers, but is also widely used by quality analysts, data analysts, business analysts, data engineers, data scientists, and many more. In this video, I will only cover the most important and the most basic SQL concepts which I believe are required to get started with SQL. I will also go through on how to write simple SQL queries. If you are in a hurry to learn SQL, then this video is for you. We will cover the following. What is SQL, overview on SQL commands, DDL and DML commands, constraints and data types, select queries, and the different functionalities associated with select. I will be making a separate tutorial style video covering all the SQL concepts in depth. So please do subscribe and hit the notification bell so you're notified when that video comes up. If you'd like me to make another video on how to write complex SQL queries, or if you wish to know more about a particular SQL concept, then please leave a comment below. If you find this video useful, then please make sure to like, subscribe and comment. It shows your appreciation for the effort I put in, also encourages me to make more interesting and useful videos for you. Let's begin. What is SQL? SQL stands for Structured Query Language, also referred to as SQL. It's a programming language which is used to interact with relational database or RDBMS. Using SQL commands, you can read data from a relational database or write data into a relational database. You can also create, modify and delete database. SQL can also be used to analyze and protect data. Almost all of the RDBMS available today, such as Oracle, MySQL, Microsoft SQL Server, PostgreSQL, IBM DB2, SQLite, MariaDB, Teradata, Hive, etc. uses SQL to manage their data. Different relational databases have created their own version of SQL, but majority of the functionality and the syntax are common across all the database. So no matter which RDBMS you use, the SQL you learn in this video will be applicable to all. I will be using PostgreSQL database. If you wish to install PostgreSQL in your machine, then please watch my previous video. Link in the description below. Before we get into SQL commands, it's important to understand that SQL is primarily used in RDBMS or Relational Database Management System. In RDBMS, data is stored in multiple tables. Each table can have a set of rows and columns. Different tables will be related to each other through certain columns forming relation. If you'd like to know more about database, then please check out my previous video on what is database and the different types of database. I'll leave a link to that video in the description below. SQL commands can be categorized into 5 types, namely DDL, which is referred to as Data Definition Language, DML, which is referred to as Data Manipulation Language, DCL, which is the Data Control Language, TCL, which is the Transaction Control Language, and finally DQL, which is the Data Query Language. Let's look at each of them in detail. DDL, Data Definition Language. SQL commands which are used to define the structure of a database object such as table, views, functions, etc. falls under the category of DDL. Using DDL commands, we can create, modify or drop any database object. The commands include create, alter, drop and truncate. As the name suggests, create is used to create a new database object such as table, view, functions, etc. Alter is used to modify the structure of an existing table, whereas drop is used to remove the database object from the database. Truncate is used to remove all the data from a table at once. The syntax to create a table can be like create table, table name followed by list of columns. Each column can be associated to a data type, and some of the columns may be associated to constraints. So let's say if you're going to create a table by the name student having a list of columns like ID, first name, last name, gender, age, etc., then the syntax would look something like this. However, in order to completely understand create table, you need to first understand what are data types and what are constraints. Let's look into them. Data type. Tables in RDBMS consist of rows and columns. Each column has a data type associated to it. Data type is like a data rule applicable to that particular column, meaning that only the data or values satisfying this data rule can be inserted into this column. There are several types of data type. However, in this video, we will only look at the 5 most basic and the most commonly used data type across all of RDBMS. Varchar. It stands for variable character. If a column is associated to varchar data type, then the values that this column can store are alphabets, numbers, alphanumeric values, as well as special characters. Int. Int stands for integer. As the name suggests, only integer values or whole numbers are allowed in int column. Date. Date data type is used to store date values. These values can be in any date format. Float. It stands for floating point numbers. It holds only decimal numbers. Finally, Boolean. It holds only two values, either true or false. It's kind of a binary representation for 0 and 1, where 1 is true and 0 is false. This table shows sample data for each data type in a table. Constraints. Constraints refers to limitations or restrictions applied to a column in a table. Constraints are very important to maintain the data integrity among tables. If you want to make sure that wrong data is not inserted into your table, then these kind of sanity checks can be applied by using constraints. Let's look at some of the most widely used constraints in RDBMS. Check constraint. Check constraint allows you to control the values that can be inserted into a column. Let's say if you have a column age and you want to make sure that only positive values are being inserted into this column, then you can use a check constraint on this column to apply this rule. So if anyone tries to insert a negative value in this column, then RDBMS will throw an error. Not null constraint. By applying not null constraint on a column, you make sure that this column will never have null or empty values. Unique constraint. Unique constraints are used to make sure that values inserted in a column across all the rows have unique or distinct values. It can help you to eliminate any duplicate data in a column. Remember, null values are allowed in a unique constraint column, and two nulls are never same. Hence, multiple rows with null values are allowed. Primary key constraint. Primary key constraint is basically a combination of unique as well as not null constraint. It will ensure that all the values in your column are unique and there are no null values. A table can only have one primary key constraint. Primary key constraint can either be applied to a single column or a combination of multiple columns in a table. Foreign key constraint. Foreign key constraint can be used to form relationship between tables. It basically helps you to create parent-child relationship between two tables, such that the child table references a column value from a parent table, so that only the values that are present in parent table can be inserted into a child table. Now that you understand constraint, data type, and create table concept, let's look at the other DDL commands. Drop. As the name suggests, drop is used to remove a database object such as table, view, functions, etc. from the database, whereas alter is used to modify the structure of an existing table. Alter can be used to rename a table or rename a column. Alter can also be used to add new columns or change the data type of an existing column. Using alter, we can also add new constraints to a table. DML, Data Manipulation Language. DML commands are used to load, modify, and remove data from the database. The commands include insert, update, and delete. Insert command can be used to load data into the table. The syntax can be like insert into table name followed by column list and then the values keyword followed by the list of values to be inserted. Mentioning the column names are not mandatory, and we can also insert multiple records using a single insert statement as shown. Update. Update command is used to modify the data in the table. The syntax can be like update table name followed by set clause followed by the column which needs to be updated, and then finally mentioning the where condition to specify the row or records which needs to be updated. We can also update multiple columns at once. Delete command will remove the data from a table. If you want to delete all records from the table, then mention the delete statement without the where condition. Else mention the where condition to specify the exact records to be deleted. Now let us use pgadmin tool to practically perform all these DDL and DML operations on a table. Let's start with create table. Here I have a create table script which basically is going to create a table by the name staff. It has multiple columns and I'm using in date varchar data types. You can see varchar data types are followed by some integer numbers. These integer numbers are nothing but limits on the number of characters allowed in this column. So staff ID column has a limit of 30 characters. So staff type column and staff ID column has a limit of 20, meaning that only maximum of 20 characters can be inserted into this column. I also have a few constraints. I have not null constraint on my first name and last name, which means that these two columns cannot have empty string or null values. I have a check constraint on gender, which basically implies that the only two values that this column can insert or can accept are M and F. Any other values being inserted into this column will be rejected and an error will be thrown. There is also a primary key column, which is my staff ID, and I have two foreign key columns, which are school ID and address ID. So basically my foreign key column school ID is basically referencing the school ID from the school table, and the foreign key address ID is referencing the address ID column from the address table. So I have already created two tables, address and school. So if I show you the data here, you can see my address has one record and my school also has one record. And now let me go ahead and let me go ahead and create my staff table. So my staff table is created. If I do a select star from staff, I can see that the table is created, but it does not have any data. So select star from is basically a syntax that is used to weave the data from a particular table. Now let me try to insert one record into my staff table. So I already have it here. So I'm doing an insert. It is executed successfully, and if I do a select star from staff now, I can see that record has been inserted. Also, I have four other insert statements that I have created just to show you how the constraints can cause errors due to insertion of wrong data. So the first one here is basically to show you the check constraint. So I'm trying to insert a value female in the column gender, and as you know, gender has a check constraint which checks that the values being inserted into this column are always M or F. Here I'm trying to insert female, and if I execute this, it throws me an error saying that violates check constraint. So this is how check constraints are useful. Going ahead, I have another insert statement, which is basically I'm trying to insert the value STF2004. As you know, in my staff table, I have already inserted a record with STF2004. So basically my staff ID is a primary key column, meaning that I cannot insert duplicate values here. So when I try to execute this statement, it's going to throw me an error saying that unique constraint violated, and this STF2004 already exists. So this is how primary key constraint works. Moving ahead, I have an insert statement where I'm trying to insert null value into the first name and last name column. Null means basically empty string, and as you can see, I have a not null constraint to these two columns, meaning that first name and last name cannot have null values. And when I try to execute this insert statement, it's going to throw me an error saying that violates not null constraint. So this is how not null constraint works. And finally, let me show you how foreign key constraint works. As you know, I have a foreign key constraint on my address ID in the staff table, which is referencing the address ID from the address table. It means that only the values which are already present in the address ID column of the address table can be inserted into the address ID column of the staff table. So if I look into my address table, I have one value, that is ADR1001. So the only value that staff column address ID can accept is ADR1001. Anything other than this value will be rejected. So here in this insert statement, if you go right, I can show you that I have a value ADR99999, which is not present in my address table, and when I try to execute it, it's going to throw me a violates foreign key constraint error, saying that ADR99999 is not present in the table address. So this is how foreign key constraint works. I hope this was clear on how we create a table with different data types and how different constraint works. Let's go ahead and check out other DDL commands. The next one is drop table. This is pretty simple, as you know that you just execute drop table name, and when you execute, this table gets dropped. So now if I do a select star from staff, you can see that this table does not exist because I have just removed this table from the database. Let me go ahead and recreate this table because I need it for now. And let's look at the other commands, the alter command. As you know, alter command is used to modify the structure of an existing table. And we can rename a table, we can rename a column, we can add new columns, we can add constraints, we can drop columns, and so many more. Here are a few examples. So let's say if I look into my staff table, I have a column by the name, I should be having, so I have a column join date, and let's say if I want to delete this column, I just execute this command, alter table, table name, drop column, join date. And now if I look into my staff table, you can see there is no join date column here. So this is how alter table works. Same way, let's say I have a column age and this one, and if I want to rename or change the data type of this column, so currently it's integer, which means int. If I want to change it to varchar, I can just execute this command which says alter table, table name, alter column, age, type, and the new data type. When I execute this, it is executed successfully, and if I look into the query, I can see I have age, but its data type has been changed from integer to character varying. Character varying is nothing but varchar. Varchar is the alias and character varying is actually the data type name. But you can use both of these names when you're creating a table or when you're using alter. It's the same. So let's say if I want to rename this table, I can just execute this command, alter table staff, rename to the new table name. And then if I try to do a select star from staff, it tells me the table does not exist because I have renamed or changed the table name from staff to staff underscore new. And now if I check select star from staff underscore new, here is my table which I have renamed. Now going ahead, let's say if I want to rename a column name. So let's say I have a column first name, I want to rename it to full name, the column this one. I can just execute this command and it will rename my column from first name to full name. Finally, if I want to add a constraint, let's say I want to add a unique constraint to my column staff type, I can just do a syntax like alter table, table name, add constraint, give any name to your constraint, followed by the constraint keyword, and then followed by the column name on which you want to apply the constraint. Once I execute this, this will create a constraint, unique key constraint on my column staff type in the table staff new. So that's how the add constraint alter table syntax works. Let me go ahead and drop my staff new table because I don't need it anymore. Let's now look at the DML commands. The DML commands includes insert, delete, and update. So my address table, I already have one record inserted into this. So let's go ahead and insert few more records. I have three different syntaxes here to insert data into this table. So the first one is if I execute this, it is successful and the data is being inserted, but you can see that I have the syntax is like insert into table name followed by the column name and then followed by the list of values that you want to insert. And I have a second syntax here which says insert into address and then followed by the list of values. I'm not specifying the column names here. Both of these are correct and both of these will work. So if I now check the select star from address, I have three records, the two records which were inserted from here and the one which was previously inserted by me. Now if I want to insert multiple records, I can execute a syntax like this. So here different record values have been separated by comma, and this basically inserts 4 records into this table. When I execute this, it shows me here insert 4, meaning that 4 records have been inserted, and when I do a select star from address, it will show me all these records that are inserted. And as you can see, all these records which are inserted have the country as United States. And let's say if I want to update any one of the country to Malaysia, and let's say if I want to update it where the address is ADR 1003, then I can just do a syntax like update table name, set the column name which you want to update, and then choose which particular record that you want to identify which has to be updated. In this case, I can identify that by using my primary key column, which is address ID. So when I execute my update statement, it will execute the command, and if I look into the data now, you can see that the ADR 1003, which is my last record, has country updated to Malaysia. Same way, I can update multiple columns in the same update statement using update table name, set the column name, and you can specify multiple columns by using a comma separator. and then specifying which particular record you want to update. So when I execute this, and if you see my address, the last record with ADR 1005 has been updated. So the country is now India and the city is now Bangalore. So finally, let us do some delete. Before that, let me just show you what we have. So in address, I have all these 7 records, and in my school table, I have 1 record. So let's say if I want to delete only one record in my address table where the country is Malaysia, I can just use where condition in my delete clause, saying that delete from table name where country equal to Malaysia. When I execute this, it just delete 1. You see here, it just deletes 1 record. So from 7, now I have 6 records, and the record where the country was Malaysia no longer exists because it is deleted. If I want to delete every record in the table, I can just do delete from the table name. So I did this for both school and address, and now if I look into my address table, you can see there are no records here and there are no records in the school table as well. However, the table exists, just that there is no data in this table. I hope this was clear and helpful. Now let us look at the DQL commands, which includes the select statement. DQL, data query language. The select statement in SQL falls under the category of DQL. Using select, we can retrieve data from one or more tables. Select can also be used to build reports, analyze data, and much more. The basic syntax to write a select statement is select column name from table name where join condition or the filter condition. Here, under the select clause, you mention all the columns which needs to be displayed when the query is executed. Under the from clause, you mention all the tables which are required to execute this query. Finally, under the where clause, you mention all the join conditions or filter conditions to fetch the desired data. There are 2 ways to write a select query. Number 1 is by using the join keyword. That is, by separating the multiple tables in your from clause by using the join keyword and then mentioning the join condition between these tables by using the on keyword. Number 2 is by using a comma separator. That is, by separating the multiple tables in your from clause by using a comma and then mentioning the join condition between these 2 tables in your where clause. Both these methods of writing query is correct, and you can follow whichever you feel comfortable with. However, I personally prefer the first method since it makes the query more cleaner and easier to understand and debug. Also very useful when writing auto-join queries. Let us now try to execute some simple select queries in pgadmin tool, which should give you a better understanding of how to write SQL select queries. We will try to cover all the SQL operators, group by statements, different types of SQL joins, subqueries, aggregate functions, etc. I've consolidated all these select queries and other SQL statements which I used in this video into a .sql file and placed it in my blog. Link in the description below. You can just download this file and execute the commands in your machine. Hopefully it should help you to practice everything you learned in this video. So I've created all these tables and loaded data into them. I've tried to design these tables to replicate a school database. We will be using these tables to write our queries. Just to give you an overview of each of these tables, so I have the school table which has the school name, the school ID, etc. I have the subject table which has all the subjects that are taught in the schools like mathematics, science, English, arts, etc. I have the staff table which has both the teaching as well as the non-teaching staff details like their name, their age, gender, etc. And the salary of each of the staff is mentioned in a separate table called staff_salary. Then I have the classes table which has information related to all the classes or grades that are taught in the school. So I have from grade 1 to grade 10 and the subjects that are taught in each grade and the teachers who are teaching these subjects. Then I have the students table which has information related to the students, their age, their name, their gender, etc. Then I have the parent information stored in the parents table. Then I have the student classes table which has information related to all the students, basically the students that are present in each of these classes. Then I have the student parent table which has information related to the parents of each student, and finally the address table which has information related to all the staff and student address. Now to get started, let us start from the most basic. The most basic query, select star from students. What this query does is it's going to fetch all the records from the students table and also display all the columns from the student table. This is because we are using a star and not specifying any column name. So a star in the select clause means select all the columns. And then since we do not have a where clause, so basically there is no filter condition or join condition. So in this way, when I execute select star from students, it's going to fetch me all the records from this table. If I want to fetch only particular column, then I can just mention the column names in the select clause, like in this case ID and first name, and only that will be displayed. Now let us look at some of the operators. There are a few operators in SQL, actually a lot of them. The most important would be the comparison operators, arithmetic operators, logical operators. In the comparison operators, we have like equal to, not equal to symbols, the greater than, less than, or the greater than equal to, or less than or equal to symbols. So let's say in the subject table, I have around there are 12 different subjects mentioned here, and I want to get only the data where the subject name is mathematics. I can use the equal to operator and then execute the query like this. So only the record where the subject name is mathematics will be fetched. But let's say if I want to fetch all the records other than the mathematics operator, then I just, instead of equal to, I just use not equal to symbol. And what this will do is it will fetch all the records other than the mathematics subject. So this is basically how equal to, not equal to works. You can either use this symbol or you can use this one, that is the exclamation and equal to symbol. They both mean not equal to operator in SQL. Now I also have operators like less than or equal to or greater than or equal to. Basically, let's say if I want to fetch all the staff details who have salary less than or equal to 10,000, then I can just use an operator like this in my where clause. So where the column name less than or equal to 10,000 and the data will be fetched. I also have a clause like order by. So let's say if I want to order or if I want to sort the data in my table, then I can use an order by clause. So for example, if I just execute select star from staff salary, you can see that I have 24 records displayed, but they are just in some random order. But let's say if I want to display everything based on by sorting the salary, then I can just mention order by salary. So what this will do is it will sort the salary column in the ascending order. So I have the minimum, that is 2,500 on the top, and then at the bottom is the one with the maximum salary, that is 15,000. If I want to sort based on this sort is the by default in ascending order. If I want to sort based on descending order, then I just mention a keyword like DESC at the end, and this data will then be sorted in the descending order. So you can see the maximum salary is on the top and the minimum salary is at the bottom. So this is how you sort data in a query. Now we have a between operator. So if I want to fetch all the salary from the staff salary table where the salary is between 5,000 and 10,000, then I can use the between clause. And the syntax is pretty simple. Select star from the table name where column name between the minimum and the maximum value. I'm also doing an order by to show the data in a more cleaner way, and you can see that all the data where the salary is starting from 5,000 and going up to 10,000 has been displayed in this query. So this is how between clause can be used. Now we also have a clause like in, as you can see here. So in the previously we saw that when I wanted to display only the record where the subject is mathematics, I used the equal to operator. But let's say I want to filter data based on multiple subjects. So I want to see all the data where the subject is mathematics, science and arts. I can use an in clause. So when I use an in clause, it will fetch me all the data where all these three values are being matched in this column subject name. And if I want to fetch the data which are other than all these three values, then I can just use a not in clause. So it's just a reversal of in clause where all the data which are not mathematics, science or arts will be displayed. So you can see here I get 9 records and none of these are mathematics, science or arts. So this is how in and not in works. Now let's say you want to match data where you are not sure of the exact value in the column, then you can use a operator like, and you can use the percentage symbol to do such that kind of matching. So let's say I want to fetch all the subject names who start with yes, whose subject name starts with yes, then I can just say that select star from the table where column name like yes percentage, and you can see there are two subjects which start from yes. Let's say if I want to know all the subjects which end with C, okay, so let's say the last character is C, and then if I do this one, it shows me that there is only one subject, that is music, which end with C. Then you can use a like operator to do such these kind of matches. Also, the two most important operators in SQL are and or. So let's look at and first. So let's say I want to fetch all the staff details who are female and who are over the age of 50. Then if I just write this query like select star from staff where age is greater than 50 and gender equal to F, what it's going to do is it's going to satisfy both these filter conditions. That is my first filter condition where the age is 50 and the second filter condition where gender is female. So basically all the records where both of these conditions are true, only those records will be shown. As you can see, all the age is greater than 50 and all the gender here is female. So this is what AND does. The conditions or the filter conditions that are mentioned on the left hand side of the AND as well as on the right hand side of the AND has to match for the query to show results. This is what AND does. Now let's look at what OR does. So what OR will do is it will try to match, it will fetch the data based on either of the matches. That is, either the age has to be over 50 or the gender has to be female. So both these conditions does not have to be true. If any one of these two conditions are true, the query will fetch results. So when I execute this, you can see that I have much more records fetched here, and all of these records you see that it will be like either the gender will be F or the age will be greater than 50. So it will never happen that the age is less than 50 and the gender is male. This kind of record will not be fetched. So basically any one of these conditions has to be successful for data to be extracted in this query. So this is what OR does. Okay. Now going ahead to the arithmetic operators. The arithmetic operators include the addition, subtraction, multiplication, division and module. In PostgreSQL, it's not mandatory to have the from clause in your query. So if you just have select also you can execute. So let's say if I want to do addition of two numbers 5 and 2, I can just write like select 5 plus 2. And I don't even have to give a name to the column. This basically total, I'm just giving a name to the column. And if I just execute this, select 5 plus 2, you see that I get my output. Just that there is no column name specified. So in order to make it more meaningful, I can specify a column name, and let me give the column name as total. I can mention this as, it's just to mention the alias. It's not mandatory. Even if I don't mention as here, it will still take total as the alias for this particular column, as you can see here. So if I want to do multiplication or subtraction or anything, we can use these arithmetic operators, which are pretty straightforward. But this is the syntax in PostgreSQL. But let's say if you want to execute similar query in Oracle or MySQL, then you will have to use the from dual clause along with this query. So select 5 plus 2 as the column name from dual. Here dual is a dummy table that is inbuilt with MySQL or Oracle DB. As I told you previously, most of the RDBMS functionality and syntax are similar, but you can still find certain syntaxes which are specific to only certain RDBMS. So in this case, this particular syntax where you can just execute a query using a select clause, I believe is only allowed in PostgreSQL. So going ahead, let's say in my staff table, I want to see all the staff type. But I see that there are so many records here, it's not very clear to know what are the unique values present here. So in order to get the unique values in a column, I can use a keyword like distinct. So select distinct column name from the table name. What it will do is it will fetch all the distinct values from this table. And now let's say if I want to, there's another keyword called as limit. Basically, let's say if I just select staff type from staff table and I see there are so many records, I'm getting 23 records. I want to only see the first 5 records. I can use a clause like limit and then mention the number. So what limit 5 does is it's only going to fetch the first 5 records from this query. So this is what limit is for. So going ahead to the case statement. Case statement is similar to if-else condition. Basically, based on certain values in your column, you can display a user-defined value. So meaning that in this particular case, in my salary table, if the salary is greater than 10,000, I want to display it as high salary. And if the salary is between 5,000 and 10,000, I want to display it as average salary. And if the salary is less than 5,000, I want to display it as too low. I can use a case statement to display this kind of values based on the different values present in the column. The syntax, as you can see, is pretty simple. Case when, the condition, then the value. And you can follow it with multiple when conditions. So when I execute this query, you can see that the salary, whenever the salary is greater than 10,000 and when the salary is greater than 10,000, the value displayed from the case statement is high salary. And when the salary is between 10,000 to 5,000, the value displayed is average salary. And when the salary is less than 5,000, the value displayed from the case statement is too low. So this is how case statements are useful. Now moving ahead to, as I told you previously, there are 2 ways to writing a query. The first way is by using a join clause, and the second way is by using a comma. So when I say using a join clause, it's basically in your from clause you can mention multiple tables. So in this case I have table 1 and table 2, and the alias that I'm giving is T1 and T2. Alias is something like a nickname given to the table. I can give this alias to a table or to columns. So I've given alias to column 1 as C1, for column 2 as C2, etc. I can use a as clause to give the alias, or I can skip that. So basically, when in my from clause, when I'm mentioning more than one table, I can separate these tables by using join, and then I can mention the join condition by using the on clause. This is one way of writing the query. The second way is in the from clause, multiple tables can be separated using comma, as you can see here, and then the join condition can be mentioned inside the where clause. I would prefer to use the first type of writing the query because it becomes more easier to read and easier to debug. You may not find the difference now, but when you write more complex and big queries, following this method of writing query really becomes very helpful. And also when writing outer join queries, this is more user readable. So I would prefer this, and most of the queries that I'm going to write in this video will be following this method of writing the query. So let's say you are asked to write a query to fetch the class name where music is taught as a subject. Basically, you want to fetch all the classes where music has been taught as a subject. Then you know that the subject name that you're looking for is music, and you know that the subject name is only present in the table subject. So your first thing that you can do is you know that your where clause has to have subject name equal to music, and the output that you're looking for is the class name. This is the value that you're looking for. So you know that the class name is not present in the subject table because the subject table only has 2 columns, that is subject ID and subject name. So in order to get the class name, you need to join the classes table, and in the classes table you have the class name as well as you have the subject ID. So you can join the subject ID from the classes table and the subject ID from the subject table to join these 2 tables, and then put a filter condition in the where clause to fetch only the data where the subject name equal to music. So now when I execute this, you can see that I am getting all the class names where music is being taught. So I can see that is grade 2, 5, 6, 7, 8, 9 and 10. These are all the different classes in this school where music has been taught as one of the subjects. So this is how you can write a simple query. Like now moving ahead, let's say to another question. So let's say if you want to fetch the full name of all the staff who teach mathematics. So basically you want to know who are the teachers who teach mathematics. In this case, you know that, okay, you're looking for where the subject is mathematics. So your first condition that you need to remember is I need to go to my subjects table, and then I need to check only for those subjects where the subject name is mathematics. This is my first filter condition. Next, the output that I'm looking for is the full name of staff. I know that the name of the staff is only present in the staff table. So in the staff table, I have first name and last name. So full name would be the combination of both these fields. So in order to combine or concatenate these two fields in SQL, we can use this kind of syntax to do the concatenation. Here I'm just giving a space. So this is basically, it can be anything, but I am using a space here to concatenate first name and last name, and then giving an alias as this is the full name. So this is what I want. I want the full name of staff. So I know that full name of staff, I can get it from the staff table. So in my from clause, I need to use staff table. And I also know that my input is that subject is mathematics. So subject name equal to mathematics. So I know that I need to use subject table. But then subject table and staff table cannot be joined because there is no matching columns. As you can see, if I look into my staff, I have the staff ID, I have the staff type, school ID. There is nothing related to subject here. And if I go to my subject table, I only have staff ID and staff subject ID and the subject name. So basically I cannot join subject table with the staff table. But then there is another table called as classes. Here I have the subject ID as well as the staff ID. So basically all the staff who teach which subject in a particular grade can be got from the classes table. That means I need to use the classes table in order to find the result for this particular query. So here that is why I am using subjects, and then I'm joining it with classes using the subject ID column, which is present in both classes as well as subjects table. And then I'm joining these both tables with the staff table using the staff ID column. So the staff ID column in the staff table is same as the teacher ID column in the classes table. So here you can see that in the classes table I have this is my classes table. I have this particular column as teacher ID, but basically this is nothing but the staff ID. Just that the column name in different tables may be different, but if they mean the same, then you can use it for joining those tables. So in this case, I'm using 3 tables, and I'm using the join conditions here, and I'm using a filter condition to fetch the data only where the subject name is mathematics. So when I execute this, you can see that I'm getting 2 teachers who are actually teaching mathematics in this school. So this is how you can form queries and execute them. So moving ahead, we have so let's say you now want to write a query where you want to fetch all the staff who teach in grade 8, 9 and 10, and also fetch all the non-teaching staff. So let's say someone from your office or from your college asks you to write or fetch all the staff details who are teaching in grade 8, 9 and 10, and also all the staff details who are non-teaching staff. In that particular case, you may have to write 2 different queries. One query is to fetch all the non-teaching staff details, and the other query is to fetch all the staff who are teaching in 8, 9 and 10 grade. To do that, what we do is we first write 2 different queries. This is the query that I write to fetch all the staff who are teaching in 8, 9 and 10. How I do that is, I know that my grade name or my class name is 8, 9 and 10, and I know that class name is only present in my classes table. So I use the classes table, I put the filter condition here, and I know that I'm only looking for staff who are teaching staff. So I put the staff type equal to teaching, which is present in my staff table. So basically I just need to join 2 tables here, staff and classes. I join it using the staff ID or the teacher ID, and then I fetch all the details like the staff type, their full name, their age, their gender. And I use a case statement here to because in my staff table I have the gender as M and F, but to make it more meaningful, I say when the gender is M, I display it as male, and when it is F, I display it as female. And I also use the join date of the staff. So this way I get all the details related. If I execute this, you can see that I get all the details, and all these are teaching staff who are teaching in grade 8, 9 and 10. But the question that was posed was that I need to get all the staff in 8, 9 and 10 and also all the non-teaching staff. So to get all the non-teaching staff, I will write another query, that is I'm fetching from the staff table. I don't need to join any other table because I don't really have any other conditions. The only condition is they have to be all the non-teaching staff. So in my staff table I have a column staff type. I just put it the staff type equal to non-teaching, and when I do that I get all the non-teaching staff details. So I have all the non-teaching staff details here, and from the above query I get all the teaching staff in 8, 9 and 10. Now whenever you want to combine multiple queries into a single query, you can use operators like union. Union is basically, it's going to union the two queries and then display the result as one. So when I execute all of this as one, you can see that I get non-teaching staff as well as teaching staff. Basically the output from both the queries are combined together using this union clause. There are a couple of rules that you need to remember whenever you're using union. The number one is that the number of columns that you use in your first query and the number of columns that you use in your second query has to be exactly the same. Also, the data type of the columns that you're using in your first query and the data type of the columns that you're using in your second query also has to be exactly the same. If there is a mismatch, then this query will give you an example. In this case, since we are fetching all the details from the staff and we are using the exact columns, we don't get any error and the query is executed. So this is there's one point to remember here. So if I execute this query, as you can see here, I have totally 16 records. And let's say if I just execute my second query here, I can see that I have totally 10 records. So 10 records for my second query, and when I execute my first query, I have around 18 records. So 18 from the first one, 10 from the second one. So it should have been actually 18 plus 10, that is 28 records. But the output that we are getting is only, I think, around 16 records, correct? So basically 12 records are missing. So you may ask, why is that? This is because we are using an union operator. In union operator, it does two things. One, it combines the result from the first query and the second query. And the number two is it removes the duplicate data. So out of this 28, 12 were duplicate, and hence it removed the duplicate and only displayed the distinct values. But let's say if you want to display all the records that you get from both these queries, then you can use a clause like union all. When you do union all, it's going to not do the second step of fetching the distinct values, and it is going to display everything that has been fetched from both of these queries. So when I execute this, you can see that the total number of records now is 28 because it's fetching all the records from both of these queries. So this is how union and union all works. Now let us look into one of the most important concepts in SQL queries, that is the group by statement. As you can see here, I'm trying to use a group by in this query. What group by is, it's going to group together data from your table and then going to fetch the results over this group. So it may not be easy to understand at first. So let us try to first look into the data in this table. So let's say I have a table called student classes, and when I execute this, you can see that I have so many data, and if I check the total number of records in this table, so I have around 1000 records in this table. So what this table is basically having is, it's basically telling each of my class, I have classes from 1 to 10, that is from grade 1 to grade 10, and it's all the students, that is a student IDs who are present in each of these classes. If I want to find out the total number of students in each class, for these kind of queries, I will need to first group by each of these class. So when I use a group by the class ID column here, basically what it's going to do is, it's going to group together all the values under this column which are same. So let's say my CLS 1001 is the ID for class 1 or grade 1. So all the records where this particular value is the same, it's going to group together and then calculate the values that we are specifying in the query. So let's say I have a requirement where I want to count the number of students in each class. How I can do that is, so I know that I need to use my table student classes because this is the table which has the students who are belonging to each class, and then I need to do a group by based on class ID. So basically for each class, what is the count is what I want. So what I do in this case is I do a select from this table, and then I do a group by the class ID. And then in my select clause, the thumb rule when you're using a group by is whatever column that you use in your group by, you need to have that column in your select clause as well. So I am using the same column in my select clause, and then followed by any aggregate function. So aggregate functions, I'll talk about aggregate functions a little later, but count is one of the aggregate functions. So aggregate function, as the name suggests, it's basically calculating a value from a set of different values. So I'm grouping by class ID, and then I'm doing a count of 1. So this count of 1, I can specify any number here. It does not have to be 1 or anything. So, but just to be more meaningful, I'm specifying it as 1, and I'm giving an alias to this column as number of students, and I'm doing an order by. So I'm just trying to sort the final result based on the class ID. So when I'm trying to execute this, you can see that I'm getting, this is my total data. So it says class 1 has 100 students, class 2 has 120 students, class 3 has 90 students, and so on. So this is how group by works. It groups together the data in your table based on particular column that you have specified, and then computes a value out of that grouped data. So I hope this was clear. This is how we are using group by. We'll look into some other examples as well. So this is one way. Now let us say that I want to fetch only those data or those classes who have more than 100 students. So more than 100 students in each class. If I want to do that, I know that I get this information from my student classes table, and I need to do a group by based on class ID, because this is the main column, right? This is when I do a group by class ID, for each class ID I'm going to get some values, and that is what I'm looking for. So I do a group by class ID, and hence I need to use the same column in my select clause as well. And since I'm trying to count the number of values, I'm trying to use the count function here, and then I'm giving an alias as number of students. But here a special condition is that I want to fetch only those records who are or those classes who are having more than 100 students. So we use another clause here that is called as having clause. This is specifically used when we are using a group by statement. So what it does is, this is kind of a where condition, where clause, but used with group by. So for the group by data that we have got from using this particular statement, we use this condition on that. So meaning that once you did the group by, that is when we did the group by, we got this record, that is totally 10 records. From this output, it's going to see where the count of 1 is greater than 100. So in this case, you can see the count of 1 greater than 100 is this one, and then this one, only 2 records. So when I execute this, now you can see that I only get 2 records. Basically, this is how group by and having clause both work together. So group by will group together different data based on the particular column that you have given, and then having clause applies a condition over that group by data. So this is how group by and having clause works. Similarly, let's say if I want to identify all the parents with more than one kid in the school. So let's say in the school there are multiple students who are kids of the same parent. So in that case, basically we want to know the parents who have more than one kid going to this school. How we can do that is, we have a table called as student parent, and if I just query this table, let me just try to query it here. So when I query this table, you can basically see it's basically having the parent ID for each student ID. So meaning that it's the parent information of each student is present here. So if I want to know, let's say if I have 3 students who belong to the same parent, then my values would be that student 1, student 2, student 3, but the parent would be parent 1, parent 1, parent 1. Okay, so this is kind of the value that this table might have. This table currently has a lot of data, so just looking one by one into all of them would not be feasible. So we need to write query by using the group by clause. So what we do is we select the data from the student parent, and then we group by the parent ID. This is the column that we need to group by, and then we again use the count, because our intention here is to count the number of records wherever the parent ID column is unique. So for each unique parent ID column, we see totally how many records of data we have in this table. We do that by using this condition, and then our additional filter condition is that we want only those records where the parent has more than one kid. That means it will have, the count will be more than 1. So for that I use a having clause saying the count greater than 1, and then when I execute this, I'm going to get this output. So basically it's tell parent 9, the parent P0019 has 2 kids, P002 has 4 kids. So if I want to check if this is true, what I can do is, let's say I go here and I put a where condition where parent ID equal to this one, and I check, okay, so here they are saying this parent has 4 kids. So just to verify if that is true, I put the parent ID here, and when I execute this, you can see that in this student parent table, for the parent ID P0002, I have 4 students linked to it. So student ID 1002, 973, 983, 988, all these 4 students are belonging to the same parent. So this is how we can use group by clause and the having clause to fetch parents with more than one kid. So this is a simple query to show you an example of how powerful group by clause is and how useful it can be when you want to compute certain data. Now moving ahead to subqueries. Subquery is basically, if you write a query inside a query, then it's basically called as a subquery. It might be useful in many cases. So let's say in this particular case, fetch the details of parents having more than one kids going to the school. So again, it's telling us that you fetch me the details of those parents who are having more than one kids going to this school. We know that, and we have seen that in order to fetch the parents who are having more than one kid, we can just use this query. So we use that query here. It's the same query here. So select parent ID from the student parent table, group by parent ID having count of 1 greater than 1. So we use this. This one will result in all the parents, or let's say if I just execute this part, it will result me in these 20 parents who are having more than one kids going to this school. So I know I need to fetch the data only for these 20 parents, and then I know that the information that I'm looking for are the parent name, the student age, student gender, their address, etc. So to do this, I will need to use a few tables, because the parent name is present in my parent table, but the student name, student age and student gender is present in the student table, and then the address, and in this case address, I'm displaying the street, city, state, country, everything. I get those information only from the address table. So I need to use address, I need to use student, I need to use parent, and then in order to identify which student belongs to which parent, I need to use the student parent table, because this is the only table which has the link between parent and student. So I need to use all these 4 tables, and I join it according to the columns which can be used to join this table. So I join my parent with student parent table using the ID and the parent ID column, and then I join with the student table using the student ID column, and then finally with the address table using the address ID column in the parent table. So I use these 4 tables. I use a subquery here to fetch only the parent ID that are having more than one kid, and then finally the select clause for the data that I want to display. So when I execute this is what I get. So for those 20 parents, they are totally having 49 students, and the information related to all these 49 students and their parents are displayed using this query. So this is how subquery works. We are using subquery, group by, and multiple joins together to execute this query. Now moving on to the aggregate functions. Aggregate functions are basically used to perform calculation on set of values. We have already seen one of them, that is count, in the previous query. There are a few more like average, min, max, sum, etc. So we'll just look at a few of them here. So let's say if I want to compute the average salary paid to all the non-teaching staff, then I can just do that by joining the staff salary table with the staff table and then putting a condition there where staff type equal to non-teaching, and then I can use an average function. This AVG is basically an inbuilt function which is used to calculate the average of the values present in the column that is mentioned here. So what it will do is, for all the number of records that this table has, it will compute the average of all the values and then display it here. So when I execute this, it tells me that the average salary of non-teaching staff in this school is 7,750. So this is how you compute average. So now let's say if I want to calculate the total sum of salary that has been the total amount of salary that is being paid to all the staff, both the teaching as well as non-teaching, then what we can do is I join the staff and staff type table. Okay, so here I'm using a group by to distinguish between the total salary that is paid to the teaching staff and the total salary that is being paid to non-teaching staff. So when I execute this, you can see that because I'm using a group by, it's grouping, and I'm using a group by based on staff type. So what it will do is it will group together all the values for distinct values present in this staff type column. So that means in my staff type column I only have two distinct values, that is teaching and non-teaching. It will group together all the values of teaching and it will group together all the values of non-teaching and then do the sum of the salary. Why it's doing the sum of the salary is because the function, the aggregate function that we are using here is sum. It's basically going to sum together all the values of salary across multiple columns. So this is how we are using group by and the aggregate sum function to calculate the salary of teaching as well as non-teaching staff. Same way we can apply the min function to calculate the minimum salary of the staff. So let's say if I execute this, it will tell me the minimum salary of teaching staff is 5,000 and the minimum salary of non-teaching staff is 2,500. Same way we can execute for the max aggregate function and we can see what is a max salary paid to teaching as well as non-teaching staff. So this is basically how aggregate functions work. Now moving on to the last section where I would like to talk about the joins. This is a very important concept you need to understand, and there are much more types of joins, but I'll be covering only the inner join and the outer join here, which I believe are the two most important types. So inner join is basically what we have already seen in all our queries. So all these joins that we used in our previous queries, everywhere that we used, is basically the inner join. What inner join tells is it only produces records where there is a match in both the tables. For example, let's say if I may show you here, so I'm going to join the staff table with the staff salary table, and if it will fetch the record for everywhere where the staff ID is common across both these tables. So let's say I go to my staff table just to show you the data, and I have around 23 staff here. So there are 23 different staff IDs present here. And then I go to my staff salary table. I again have staff ID and I have 24 records here. So basically there is one additional staff ID mentioned here, or maybe it can be different because the staff IDs might be different. So it means that there are certain staff that are present in staff salary which are not present in staff. It may not happen actually in the real world scenario, but I've just created data like this just to show you an example. So when I do an inner join, what it does is it will match with the staff ID present in both this table and then show you the result. So I've written a query here. So I'm joining staff table with the staff salary table using the staff ID. And when I take, so I can use a count function here. I'm not using group by. So it means that we can use these aggregate functions with group by or without group by. It does not matter. So if you use it with the group by, it will fetch the result for that group together data, and if you don't use group by, it will fetch the result for the whole table, set of tables. So when I do a count of 1 for this join and execute it, tells me 21. It means that there are 21 records or 21 staff ID which is matching between the staff and the staff salary table. So it means that out of the 23 staff that are totally present here, so I have totally 23 staff, only 21 matches with staff salary table. Okay, and now if I look here, I have in my staff salary, I have 24 records. There are totally 24 records, of which only 21 match with staff table. So this is a good indication to say that there are some staff information present in the staff salary table which are not the staff which are not present in staff table, and vice versa. So when I do an inner join, only 21 records are fetched because these are the 21 records that are present in both this table. And if I want to see the data, you can just see that. So these are all my the staff name, and this is the salary. So these are all the 21 staff whose information is also present in the staff salary as well as in the staff table. This is what inner join does. So we can either use the syntax like join, or I can specify this as inner join. Both are same and both have the same functionality. So even when I use inner join, this output is still the same. So it does not matter whether you use the clause as inner join or you just use join. So it's up to you what you want to use. So going ahead, the second type of join that we have is outer join. And under outer join, we have 3 types of join: the left outer join, right outer join, and the full outer join. So what these joins means is, the left outer join, what it does is, it's going to fetch all the result from the leftmost table and then show you the results. The right outer join will fetch all the results from the rightmost table and then show you the results. And the full outer join is basically going to show you all the records which are present in both left and the right table. Let me explain you further. So now let's say I go to this particular query here. I'm doing a left outer join. So I'm doing a select from staff table, joining it with a staff salary table on the staff ID. But instead of doing a normal inner join, I'm using a left join. So what this means is, which is my leftmost table, in this case staff. So it's going to fetch all the records from the staff table. And you know that in my staff table, as I showed you, we have totally 23 records and only 21 matches with staff salary. So there are 2 additional records here which do not match with staff salary. But when I use a left join, it's going to even fetch me those 2 records which are not actually matching with this particular condition. So that is what a left join does. So when I execute this, it's going to fetch me 23. And if I show you the actual names, you can see here you can see here that I have all the names. Out of the 23, for 21 records, you can see I have the salary information. For the last 2, I don't have the salary information. Hence it is mentioned as null or empty, meaning that these 2 staffs are only present in my leftmost table, but they are not present in my right table. So in this case, the left table is staff and the right table is staff salary. So this is how a left join works. It will fetch all the records that are matching with both the tables. Additionally, it's also going to fetch all the records which are additionally present in my leftmost table. So this is what left outer join does. And if you go to the right outer join, as you can imagine, it's basically the same as left, just that it's going to match all the records from the rightmost table. So when I execute this, I'll get 24 records. This is because, if you remember, in my staff salary, totally it has 24 records, 21 of them match and 3 of them are basically only present in staff salary and not present in staff. So when I do this right join, I'm getting 24 records. And when I see the data here, you can see that if I go down, okay, you can see here that there are 3 records where it is showing null as the full name is null, but it has salary, meaning that the staff salary table has record for these 3, but the staff table does not have. But since we are using a right join, it's fetching even these records. So the 21 records which is present in both the tables, and the 3 records which are only present in the rightmost table is shown. So totally 24. This is what right outer join does. And finally, full outer join. What full outer join does is it's going to match the records which are matching in both the tables. So, and then also going to show you the data which are present only in the left table, and also show you all the data which are only present in the right table. So when I do an execution of this, and the only difference is I'm using a full outer join, I get 26 records. This is because there are 21 records matching in both these tables, and then there are 2 records which are only present in my leftmost table, and then there are 3 records which are only present in my rightmost table. So it will show me everything, that is 21 plus 2 plus 3, that is total 26 records. So when I execute this and show you the result, you can see that this particular record, meaning that it's present in my leftmost table, that is staff table, but not present in my staff salary table. Going ahead, and the same thing goes here for this record. Going ahead, I have these 3 records which are only present in my staff salary table, but there is no data for that staff ID in the staff table. So this is how full outer join works. So